that should be working. Good. And you can see the mouse. Good. Excellent. That all seems to be working. Sorry about that delay, everyone. I tried to keep Railnatter pretty regular, but there's a literal thunderstorm outside. Or actually, it was kind of the tail end of one, but I didn't want to risk it. I didn't want to risk... Well, I don't really know, to be honest, but something bad's happening with static or the internet going out or me getting electrocuted through my computer screen. Tonight is... It's not going to be a particularly... it's going to be, I think, hopefully... I always say this and then it ends up being an absolute gargantuan beast. Hopefully it's going to be a bit of a snappy one because I've saved up lots of news for next week. It'll be a news episode because there's so much that's happened while I've been away. Good grief. There is a bit of news, though, which I'm going to include, which is... here we go again. Here is it Marie-Anne Trevelyan is the new... Is that right? Is that who it is? I think it is. It's the new. It is the new Secretary of State for Transport. Yes, and yeah. It basically she. Well, I don't know. Yeah, Anne Marie. Sorry, I got that the wrong way around. Anne Marie Trevelyan. Forgive me. MP from up the north east, north of Morpeth, actually. I think right up in the top corner of England. Which is interesting for HS2 Eastern Leg reasons, but don't anyone get your hope up because. I can see absolutely nothing good happening under this collection, this gaggle of sociopaths that are now in charge of the country. But anyway, there are new Secretary of State, our special boy, Grant Shapps. We'll next week we'll review what our poor special boy is up to. What is his new life, having been kicked off, having had his baby that he created and put his bloody name against the Williams Shapps plan for rail. Always mistrust someone who's willing to put their name against reports. Yeah. In any case, there we are. Ryan Hogg, Ryan Hogg's MP, Berwick, and a climate change denier. There you go. Thanks, Ryan. Yes, wonderful. Exciting thing for the next week's news is that there'll be a section of it we guest edited, which should be fun. Those of you who submitted, it's just one of you who submitted news for next week. You know who you are. You can submit news suggestions to me on the Discord via the Patreon channels. You have that power, folks. If you're a Patreon subscriber, you can recommend news items to me via the Discord. Right. Anyway, what next? Well, what's next is we're going to do it. We're going to dive in. This is an interesting little history episode, really, because we're talking about the work that was done to deliver 125 mile an hour mainline, or rather a 200 kilometre an hour mainline, Britain's first 200 kilometre an hour mainline, which was between really it was kind of up to Wootton Bassett Junction, to be honest. It was from Paddington out to Wootton Bassett Junction, but we will do so through the medium of a paper, but we'll talk about that momentarily. So tonight we'll be talking about how you do that. What work do you do to do that? Or rather, what work did you do in the 70s to achieve that? And how would it look today if you did it? And could we do the same thing today? And what are the upsides and downsides of having done this work? It's going to be a bit of a discursive one. It should be nice and interactive because it's going to be a nice, easy, straightforward episode. Bit of a page turn of a report, but also we'll just generally do some discussion about what was done then, what work perhaps isn't mentioned in this report. That I'm going to refer to. Anyway, right, enough of that. Everyone, it's a bit late, but welcome to tonight's Railnatter. And as the Intercity 225 fades away... Oh, let's bring a picture of this device up. I tweeted this a while back. It's an image from the paper, actually. And it's fascinating because it's this little device that was mounted in the train it traced track quality, is the point of it. It traced track quality. And this is an example, a really nice example of, it's a really nice example of what. In fact, let's get my little miniaturized face. Hello, everyone. I'm here. It's a really nice example of the sorts of innovation that you can see being developed for the benefit of for the benefit of a getting running a better railway, but that can be achieved by a state organisation. And you constantly hear this made up nonsense about state organisations cannot innovate, and it just isn't true. Not least as pretty much all of the main innovations that people wave around as being achieved by the private sector have been entirely enabled by the public sector. I've just seen so few. I can think of no examples, and I've seen so few examples where it's literally true that private enterprise has come up with that with the innovation itself. So it's an interesting and weird, interesting and very weird sort of myth. So anyway, to that, we're going to talk about. We're not going to talk about this thing. Here's the prototype Intercity HST, Intercity 125. Here's the prototype with a rake of Mark III in development coaches. This is it in 1975. It's at Didcot. Quite a bit of work had already been done at this point, as we're going to discuss momentarily. Yeah. Oh, yeah. That's a good point, Gareth Williams. I might talk about the whole. I tell you what. I'll do a little before the end. I'll do a little treat chat about the holiday, shall we? Because there are a couple of interesting things I think are worth just picking up. Anyway, yes, this train. It was not just this train that enabled those speeds. It helped. Don't get me wrong, but the infrastructure was a bit of a mess along the Great Western, and indeed basically around the whole network to enable these upgrades to happen. So we get an understanding by kind of hopefully this paper will give us an understanding of the physical work that happened to enable that speed. So let's get into it. The paper I'm going to be referring to, indeed we're doing a page turn. It's just going to be a nice page turn. Chuck all your questions, thoughts. It's going to be a nice interactive one. Yeah. So, all right, here's Penny Mordaunt talking about the top 180 innovations. Yes, quite. Thanks, Doorhanger 93. We're past that. We don't have to think about it anymore. It's not going to hurt us. So John Perry's already asked an interesting question. And I think the paper maybe touches on this, actually. John Perry asks, did the fact that the GWR was initially broad gauge affect or make it easier for its reconstruction to 125 mile an hour operation later? Gareth Williams also makes a very good point. John, yes, in some places, but not particularly in other places, because contrary to what a lot of people often make the mistake of, for example, the increased track gauge was not accompanied by a commensurate increase in loading gauge. In fact, loading gauge was reasonably restrictive. And so in order to make the most of the extra space that broad gauge provided, you needed to, you couldn't take the use of the width of the formation because you still had a gauge clearance challenge. For example, the other issue is that quite a lot of the infrastructure had actually been rebuilt and encroaching back to match the standard gauge by this point in a few places. I think they'll perhaps touch on it. So we'll go through and we'll have a look at the paper to kind of get that one. Gareth Williams, you're right. The only really innovative thing that the private sector can do is work out how to avoid paying its fair share in tax. Yeah, I would agree with that. Couple of Imperial graduates in there. Oh, interesting. Yes, I can believe it. R.J. Collins, J. Black, and J.E. Tyrer. Their paper, which is published in the... if you're an IC member, you can go in and download it, or if you have an academic access, you should be able to download it. High-speed track on the western region of British Railways. That is the paper. And we're gonna go through it and have a look. Let's wing it up right now. Here it is. My plan is to just go through page by page. I think this is large enough for everyone to read, right? If you really want, so you're going to get the whole thing here, anyway. So you don't have to download it. You're gonna get to see it here as I go through and look at it. Indeed, this paper is here. Here's the little abstract. It's going to describe the work which was and indeed was still being carried out to provide the necessary track standards for 125 mile per hour running. It's weird to see them write mile/hour. There. I was writing it kind of probably more correctly than MPH, which is kind of interesting. Running between London and the outskirts of Bristol. The very large number of items of work, including realignment, ballasting, treatment of foundations, switch and crossing work, remodelling, and elimination of level crossings, required the special provision of resources and occupations of the line, which in one case involved the closure of a route for 5 months continuously. There are lots of interesting things in this, by the way, that are worth us pulling out. One of them is a reminder that we were fairly recently still comfortable with closing a bit of railway line for a very long period of time. The Badminton line, by the way, is the line from Wootton Bassett Junction to the Severn Tunnel. So, actually, no, it's the line, it goes to as far as Bristol Parkway, I think, is technically the Badminton line. But anyway, it's that bit. It's the bit that goes to Bristol Parkway rather than Bristol Temple Meads on the old road. It's not many pages, by the way. This is not a huge... it is not a huge paper. It's amazing how many of the hello Rail Natter diehards following this. I'm glad that you enjoy a PDF page turn. Some might say it's lazy content. Those people would be absolutely spot on. Yeah, it was. I was back from a holiday. This has given me a chance to also wreck my throat, which is not good. Wait a minute. Oh, there we are, I'm back. I don't know why I've got stuff caught in my throat. It's because I just had a plate of beans. Anyway, yeah, we're going to go through and hopefully I'll add some insight. And the discussion in the chat will mean that we'll get more out of this than if you just read the PDF on your own. But if you don't, then you don't have to subscribe to the Patreon, or you can send me an angry comment. That's also fine. As long as you do, as long as you like the video and subscribe, that's all good. Anyway, so... let's talk. So this is interesting because there's a bit of history in here. This is discussing most of the work that happened to enable 125 miles an hour. There are a few really nice diagrams in here and some quite nice stuff. Oh, actually, that's a good point. In fact, I can do this right now. You can watch me do this right now because I think there are a couple of pages that would benefit from, for example, this one. Benefit from being rotated. There we go. That's rotated. This one could do it being rotated as well. There we are. This one. Let's rotate this one. You're getting a little tease here. Rotate. Fine. Yeah, good. Cover your eyes. That was a bit flashy. Anyway, right. It's only about, what was that? Like eight or 9 pages. It's not many. So, we start in 1970, and at this point there was a detailed study being made as late as 1970, you might think, but yes, indeed, there was a study being made of how to replace the aging rolling stock on the kind of the main line between London, Bristol, and indeed South Wales, and an understanding. It's interesting. The other thing that's interesting is that there's an understanding of this increased competition from the M4 motorway, which by this point was a well-established bit of infrastructure. And it was concluded that the provision of an intensive service of diesel trains running at speeds of up to 125 miles an hour, either high-speed trains or HST is what they're referring to here. They're saying the HST would meet the situation and give the best return on the investment involved. So there you go. Very interesting little tidbit there. There's the understanding of the need to respond. Weird that it's, at this point, a nationalised railway is having to compete with a form of nationalised infrastructure, which is the motorway network. But anyway, it's another story, isn't it? Table 1 gives comparative... Sorry, basically, the immediate thing they realise is that we're going to kick off with this is the challenge with, for example, higher speeds over jointed track was something that they understood that was the challenge. So there's a bit of a discussion here about what the favour design of rolling stock was. So kind of minimising the axle loads to avoid too much damage where there was jointed track at high speed. But also the fact that they're understanding that they need to improve the condition of the track, the quality of the track, and supporting materials as well to enable these higher speeds. So here we are. Here's IKB. Isambard Kingdom Brunel, the engineer to the Great Western Rail. We're out to see some 1970s propaganda here. In his grand concept of the broad gauge railway designed for speed, stability and robustness, provided an alignment from London to Wootton Bassett with easy gradients, flat curves and very few level crossings. So the point really, to answer John's question, is that it's not so much actually the broad gauge that was the benefit here. It was the fact that Brunel did build Britain's first high-speed intercity mainline. Arguably over-designed it quite substantially, other than in the P-Way, which itself was so dreadful it had to be replaced almost immediately after he opened it. Brunel himself, not actually a great engineer. He's very much the Musk-type character of his day, and I don't mean that as a compliment. However, what is interesting, what is useful is that he did choose to, again, his design, firstly, broad gauge was an economic disaster. It should never have been chosen as broad gauge. It limited the economic potential of all of the areas that relied on his railway for a very long time, and they only bumped back up the level with everyone else once they'd been corrected and had interlaced kind of mixed gauge or standard gauge. So broad gauge was a disaster economically. It was a dreadful idea. The other issue with his infrastructure was that he stunted the suburban development of both Bristol and particularly London by building a railway that didn't have any intermediate, or didn't particularly have intermediate stations on it. So he designed an intercity railway, great, without first having a suburban railway network to serve it. So that was also interesting. But the benefit of that for the engineers at this point was that they had a pretty decent alignment. It was pretty straight at that point. Matt Reed, are there any other papers like this for other lines? Yes, there are. In theory, these exist kind of through the ages, and at some point I'll maybe go through a couple of PWI ones, because I've got pretty much every journal back for a very long time behind me. If ever you wonder what the light blue is, let's go big face momentarily. If ever you wonder what this lot is here, this is a letter. I don't know what that is. This stuff, these are all PWI journals. Also a load of business cards and some gold paint sprays and a Pandrel clip. Don't worry about those. And also a load of rail tickets as well there, and obviously a RailNet merch mask, and some Lego P-Way gangers. But anyway, all of these are PWI journals, and they, at some point we might pick some others. So if you've got thoughts or things that you want, at some point we'll do we can flick through. Maybe I'll do it as a bonus episode at some point for some folks, and we can go through and pick some things that we'll do in the main natter. Anyway, so yes, Matt Reed, there are other things that are quite interesting to look at in history, and if you find this as an interesting episode, then we can definitely do more of those. So, So there we are. So thus the western region of British Railways inherited a natural high-speed route through the Thames Valley and Vale of Whitehorse to Wootton Bassett, where the meandering Avon Valley and the southern slopes of the Cotswold Hills required a more sharply curved alignment. Fine. The geology of the route varied from the gravel beds of the Thames Valley, mixed with lengths of London clay, to the softer clay, sometimes layered with limestone of the Cotswolds. Most of the major cuttings and embankments were cut through and tipped with clay of varying strength. So it's not great. Clay is always a bit of a red flag for earthworks, because it has a nasty habit of being impermeable and water sitting on it, and then it also absorbs and swells and desiccates horribly. Jamie B, what train nerd doesn't have a massive stack of train tickets on a shelf somewhere? Well, indeed, exactly. So, in order to provide this sort of upgrade, the speeds, they're pointing out here, the speeds are 25% higher than those achieved on the route kind of previously. They required an improvement in the quality of the track geometry. Now, this is a key point. So, as speed increases, you are exponentially increasing the loads, the dynamic loads that are going down into the track. I don't know if I've done this in a previous episode actually, but talking about kind of track kind of dynamics and the way that track behaves, it's not linear. The main loads that we have to deal with this track is not the static weight of a train on top of it. That's not really an issue. That's an issue for the bridge people. It's really not an issue for track people, at least not in the UK really with our current suite of track materials. The issue for our track materials is the dynamic forces, the dynamic loads going into them, and by dynamic I mean there is a time element. So it's accounting for speed, and as the speeds go up, essentially you get a much greater. So if you've got a bump or a kink or a slight track twist, or if you're going over, say you've got a slight track twist, say you experience it's the same shaped track twist, no matter what happens. You've got a track twist kind of in the track. I'm for the people in audio only mode, I'm fingering a little dent in the track here. So one track's straight and the other track's got a bit of a kink in it. If you imagine, you've got the two tracks going along. If you go along at 15 miles an hour, your train is going to kind of roll like this and then roll back, and it won't be great. But it's not going to result in a bang of any kind. If you imagine that you're going at 50 miles an hour, actually there might be a bit of a bang as you drop into the hole, and then a bit of a bang as you climb back out of it. If you can imagine going through at 100 miles an hour, that dip is going to be basically the wheel is going to fly off but drop slightly as it flies through that dip, and then it's going to hit the other side with tremendous force, resulting in an enormous bang. That difference in the loads that are going down into the track, and indeed up into the rolling stock, the speed is a dynamic. There's a dynamic element there. The speed changes the loads, so that's important. That's really important for understanding that if you've got track geometry with a certain, you can allow a certain level of degradation of the designed track geometry, so the perfect curvature to make sure things are nice and smooth. If you have if you've got lower speeds, that track geometry, you can allow it to go out a bit. Maintenance can sort of not be quite as rigorous in maintaining that alignment, and keep in order to keep the trains safe and minimise those track forces. Whereas at higher speeds, those tolerances, you have to be more careful with the extent, the quality of the track geometry and how well it's maintained, how smooth it is, because you're gonna, at kind of the lighter end, you're going to be damaging rolling stock or increasing maintenance long-term damaging materials. But if you go to extreme circumstances, then you might derail a train. That's not good. So they knew the engineers at the time knew this, and they knew this to quite decent levels of detail. And for all those people who talk about the fact that we should be measuring stuff in inches and miles and feet and yards, well, okay, we have used miles as a location positioning system for a long time on the railway and still do, but really it's totally discrete from actually being a measured distance. You'll see later on, okay, we still use yards in a few places, but they use millimeters quite a lot in this because as a scientific, as an engineer, it's a much easier, metric units are much easier to work with. So they end up doing this an analysis of the existing curvature of the route, which is interesting. Looking at how you would achieve continuous high-speed running, which is important. We talked about the fact that you want to fix the low-speed stuff. We'll get to that. But it was also referring to the fact that, so you can see that, blah, blah, blah. So you had some minor adjustments to allow higher speeds, but overall the work that they needed included major realignment at 8 sites, which we'll refer to in Figure 2 in the next page. These sites were mainly where Brunel's original alignment had been subsequently modified, which is interesting. It's interesting to observe that. Minor adjustments to cant and transition lengths were required over about 90 track miles. So if you increase speed, a transition is a change between two different types of two different radiuses of regular geometry, if you like. Straight is a curve with infinite radius. So if you imagine regular geometry is it has a sort of standard curvature. It's a circle. It's a part of a circle, and you connect those bits of circle whether they're in the same direction, sharper and slacker, tighter and slacker curves, or whether it's a straight and then a curve coming off it, or whether it's perhaps a curve in different directions. Wait, that way, yeah, like that. So kind of coming up and then going up. I can't. It's not PowerPoint, so I can't do nice scribbles on the. You get what I mean. Anyway, so. Transitions connect those different types of geometry, and as you get faster, those transitions are doing two things. They're transitioning cant, which is the inclination of one rail above the other, through a curve to balance or indeed not balance lateral forces. The other thing they're doing is balancing the unbalanced forces. Is transitioning through the unbalanced forces. So you're transitioning the physical changing cant, so the actual tilt of the track if you're in cross section, but also you are altering the whether you have cant or not, there are different lateral forces on the train. So if the train is kind of, as you're in the train, you can feel the train going this way and that way. Transitions are what allow us to move through if you're going around a regular geometry curve, you'll kind of have the same force being applied to you. But then as you go into a different curve, you'll have a different force applied to you. And the change from I'm being leaned this way to, I'm being leaned this way, if that happens too quickly, oh god, that's not comfortable, and I'm sure all of you have been on a train that's felt like that, that means the transition's too short, or there's maybe a twist or other issues like that. So getting the transition lengths right is important, and as you increase speeds, you potentially need to increase those transition lengths. So that's one thing you need to do, and it's not just it's actually not easy. It's not just a super easy thing to do to increase transition lengths, because as you increase transition length, you increase what's known as a shift, which means you actually the geometry will kick out where you're increasing the transition length. So you might find that it's not a simple case of you just fine, you just extend the transition, easy, right? You decide a new alignment and you adjust the track accordingly. It might mean that you need to actually increase the formation or alter the alignment and the bearing of curves or straights on either side. So not quite as straightforward as it might sound. So yes, that's one thing they need to do, minor adjustments to cant and transition lengths over about 90 miles. And the major sites were Twyford, Purley, Pangbourne, Chippenham, Thingley, Hullavington, not a real place, that's made up. Chipping Sodbury, also not a real place, and Culpit Heath. Chipping Sodbury is where people who live in biscuit tins are from, right? Anyway, so those are the various places that major work needed to be done. What's also interesting is that they did a stupendous amount of ground investigation for this. So they did trial holes at 100-yard intervals right the way through the route on both of the main tracks, which is an enormous amount of ground investigation work, just absolutely spectacular. Always do the work, always do the survey work, and they did. And the reason they needed that is because they knew the criticality of getting the subgrade, the formation, what's underneath the ballast, but also the ballast, the condition of the ballast as well. But they needed to get the condition of everything underneath the track so that they could prove that running at 125 miles an hour would be safe. Yes. But chiefly it was looking at ballast and formation conditions, because if ballast was in a poor condition, they knew that the dynamic behaviour of the track. Ballast, when it's fresh and clean, is a fantastic material. It creates a nice interlocking matrix of solid granite that's free draining. It's as sturdy as it needs to be, but also is a bit springy. It's perfectly balanced if it's the right material. And as we'll see later on, not all of the ballast was the right material. A couple of questions. David Shepherd asked, do you know of any sort of stop 125 mile an hour movement that oppose this plan? No, I don't actually, but someone else might. Someone else might know that. Dave, did they have a PLPR? That's a plain line pattern recognition. Banana train equivalent back then. We'll get to that too. What are the French doing at this time? We might not get to that in this one, but at this time, what is it, in the 70s? I don't know, actually. I'd be stabbing wildly in the dark at this point, but I'm guessing not dissimilar. Although we were, in certain elements of railway research, we were ahead of the curve. But I would guess that given that they were developing, well in advance of their development of high-speed rail, they were also doing a good job of doing this sort of trace analysis for track geometry. Jamie B, is the lateral need for transition somewhat countered by bogies for slow speeds, at least in theory? Yes. But not much. Bogies allow you on certain types of change in geometry to have what's called a virtual transition. We make an assumption about the fact that the two bogies essentially create a transition as they pass instantaneously from one type of geometry to the next. The trouble is, a few things with that virtual transition. And I could do a whole episode on virtual transitions, and maybe I will. Maybe I'll torture you all with that. But virtual transitions, firstly, can't be installed by a tamper. The tamper will always install a transition because the tamper has its own length. So it will always install a type of transition. Secondly, virtual transitions work at slight changes in geometry. So that works between two pretty similar curves. But ideally, you don't really want to have two quite similar curves because that can be quite hard to maintain two similar curves next to each other. Ideally, you want to standardize that into one curve to minimize the number of elements. The other issue is that if you have it between, you can use them at lower speeds. We often use them pretty much always use them in depots, for example, virtual transitions. So yes, we can use those, but you always have to account for the fact that they're, you might have a rolling stock going over that does not have bogies, but primarily the issue is that it's not maintainable. It's not installable, it's not maintainable, and it's not great practice. So we try and avoid virtual transitions, but they are used all over the place and still in new designs as well. We do use them. Even HS2 will have virtual transition. Oh, does it? I think it might actually have some virtual transitions into the stations, but possibly. I can't remember exactly on that one. Anyway, Tom Selleck. The embankment east of Bristol Parkway, Winterbourne, was slipping. Lots of ballast was dropped during the 1970s. Yes, we will get to that. That's the Badminton line, and there were serious issues with drop ballast. We'll get to that. Thanks, Tom. Very interesting input. So, good questions, everyone. This is a good rail now. I love when everyone's getting involved. Lovely to have you along. This is what it's all about. Everyone getting stuck in. If you've got questions, by the way, make sure you at me so I see my name. I kind of pass over the other comments. I assume they're people chatting amongst each other. John Quine is watching RealNat reviewing old journal papers rather than reviewing new journal papers for my dissertation. My dissertation, the definition of procrastination. Yes, it is. Yeah, sorry, John. I'm really sorry, but this is procrastination, and it's exactly the sort of thing I would be doing at that point as well. So, the volume of track work required that additional resources be provided to allow its completion whilst the usual programme of maintenance and renewal throughout the region was being carried out at the same time. So they knew that there'd be a need to kind of an uplift in the staff required. Levels of staffing, plant and equipment were all raised with the provision of, for example, additional automatic ballast cleaners, tampers, liners and hopper wagons for conveying ballast. So a reminder for anyone who thinks the automatic ballast cleaner technology is new, or at least is only 10 years old. We've been using automatic ballast cleaners since the 60s. And indeed, quite a few bits of the railway were using them quite a lot before that as well. If you want to find out more about that, then I can heartily recommend Andrew Dow's book, The Railway, which is behind me, which is very good. I'm not going to get it out because it's very big and I'll fall over. Lots of additional so things that we can learn, by the way. There's lots that we can learn about the work that was being done. So anyone from Network Rail listening to this, there's things that you can pay attention to. For example, the fact that it was a long-term projected plan meant that they could increase staffing in advance of the work. Rolling program. Actually, that's not a lesson Network Rail needs to learn. It's a lesson that government needs to learn. They ain't going to learn it. Anyway, what else? They discussed extensively in advance, like a long time in advance, and this is something that we do generally do with the operating department, as it was then, to allow the track work to be to kind of put these possessions in, long blockades rather of the railway, as well as the temporary speed restrictions, so coordinating the temporary speed restrictions once the work had been done. Nowadays we can get past a few of the temporary speed restrictions by using a dynamic track stabilizer to actually accelerate. That emulates the traffic going over it to bed the track in, but you can't do that for everything. It's not quite as straightforward to do with switches and crossings, for example. There's the point where trains change direction. So the target dates were set. Target dates for raising the line speed to 125 miles an hour were set as October 1976 for Paddington to Westerly Junction, May 1977 for Westerly Junction to Bristol Parkway, and May 1978 for Wootton Bassett Junction to Box. There you go. Let's hop to the next section. Here's that map that you saw earlier. So here's the high-speed route, as it were, and it includes both the Badminton line, here it is, Badminton line, and also the old road, as it were, via Box and then Bath. So we have the various dates. And what's interesting here is potentially an interesting little table, is to look at the different, both the static wheel load of a different vehicles and arrangements. So you can see the Deltic's pretty light. High-speed trains, also pretty light. AL6 pretty heavy, so that's what was then being what was kind of starting to be referred to as the Class 86. Is it's a couple of tons heavier. You can see that 100-ton wagons are quite substantially heavier. Interestingly, you can see here Freightliner wagons, already Freightliner entering the vernacular at this point. So some lovely data for you there. Some unsprung mass as well there. Unsprung mass being absolutely relevant. The Deltic was pretty poor on unsprung mass, whereas the unsprung mass is how much mass is below the suspension. So essentially there isn't having the benefit of the suspension to damp out the dynamic forces. So everything below the suspension is unsprung. Everything above the suspension is sprung mass. And the advantage of sprung mass is that the suspension takes out some of those dynamic elements, those dynamic loads that we talked about. Also interesting here is that you've got the various speeds. So you've got the speeds referred to. Isn't that nice? Some nice data. And then the P1 and P2 figures, which are related to dynamic load of a train doing its thing at speed. There you are. Some nice data for you. Peter Kress. Oh, your message is gone. Peter Crees. I do apologise. Peter, I'm not... yeah. Once you've successful, you're probably having trouble with the atting. That's no problem. When you sent the question, I'll answer it. No bother. So alignments. This is what is referred to often as an LSI type scheme, a line speed improvement scheme. But I'm trying to get the industry away from calling them that because it's not helpful. It's really not helpful. I think that we should be looking at considering a holistic view during time improvements. But that's another story and another rail matter. In the meantime, the work that we're doing here was looking at obviously increasing the top speed to 125 from what I think was a mostly 90 mile an hour railway with quite a lot of shorter bits. Barry Jones is saying those awful numbers of why they added secondary suspension to the Class 86. Yeah, it's got really bad unsprung mass. Yeah, I think you're right. Like the 86 was not great to start with. In fact, quite a few of the early... Well, the 86 was the... essentially was the embodiment of everything that had been learned in the first 5 kind of prototype classes, really, haven't they? Correct me if I'm wrong on that one, Barry, but I believe that was the 86 kind of captured everything that had been learned by the preceding 5. It was closest to the 85? I can't remember. In any case, that's the 86, and the unsprung mass not great there, as you can see. Not very good at all. So anyway, I'm getting distracted. What's nice is we've got a variety of interesting things here. So we're going to go through analysis of the route, based on the requirements of British Rail Handbook number 3, which has been long absorbed into various BR standards. Peter, I'm glad you got the question right, because it's a very interesting one, which I'll come to in a minute when I finish this page. If I forget, remind me. The analysis of the route based on the requirements of Handbook number 3, what is now actually being shifted again from Handbook 40, what was Handbook 49 now into 2102, the latest kind of the Network Rail standard. That please tell me that was not a flash of lightning again. I think it might have been. Anyway, 2102, which is the track construction standard now. But basically, it sets out the rules for speeds of trains in relation to radius, cant, length of transition, all that stuff. Those standards, which I think I've discussed those standards before on when I've done geometry discussions on here, and if not, then I've done it in the Permanent Way episode, or an episode of the Permanent Way, which is a series hidden somewhere in my channel. It was short-lived because I got preoccupied with Transport Fever 2. These are based on experience, it's true, and indicate the values which will be acceptable for passenger comfort and provide an adequate factor of safety. And it refers to Table 3, and here's Table 3, which is interesting. It's interesting because it shows that the design standard, the standard design criteria haven't really changed, actually, except for a couple of interesting points. One of them is that we have... firstly, we've actually increased our maximum rate of change of cant and cant efficiency from 45 to 55 millimeters per second. So we can actually tolerate a slightly larger kind of jerk, which is interesting. But the maximum cant absolutely is still the same, 150 mil and 110 at through stations. And maximum cant efficiency is 110. So those are still the same standards we designed to today. So yeah, there's some of the kind of bits of detail that are kind of present here. So we're going to go through a couple of the sort of sections, and the first we're going to look at is Twyford Station. So the GWR quadrupled the tracks through Twyford Station in 1893, and the original tracks were used as the relief lines, while the main lines were established on a new formation alongside the existing tracks. This involved sharp reverse curves, which were tied in the middle by the platform walls and at each end by the bridges, resulting in a permanent speed restriction down to 75 miles an hour on the main lines. So in 1966, by taking maximum advantage of relaxed cant efficiency rules and additional reverse curves to improve the transitions, the permanent restriction of speed was improved to 90. This is the maximum speed possible without incurring major reconstruction. But they decided to do that reconstruction work in order to achieve the 125 miles an hour through Twyford. So it's quite interesting. There's this. If we jump to this page here, you can see the whole story as to the allowable speeds through from Paddington. So you can sort of see this is the before speeds here and then the after speeds here. This is quite interesting. It's interesting to compare with what the current arrangement is actually. Does it still have this restriction through Reading? Or have they got rid of have they eased the restriction? I'm not sure. In any case, you can see they've got, coming out of Paddington, you've got 25, and then there's some stuff on the up, but you get onto 90, and then it's 100, then a drop to 90 through Twyford, then up to 100, and then a drop to 75 or 80 through Reading, and then there's a bit of acceleration up to Pangbourne, 100, 90, and then through Didcot it's 100, and then basically beyond the 65 mile post or 64 mile post, you sat at 90. And you can see that the plan then was to basically create as much 125 as possible. So these are really nice diagrams. I think they're really useful. And then from the 80 to 115 mile post, you can see 90, then a bit of 70, then 90, then 60, 90, 60, 90. Bit of a hodgepodge. You can see the hodgepodge kind of remains, but given there's the curvature at this point is a bit tighter, so you can see that there's seconds of 100, 125, 110, 125 in the final state, in the proposed state. So that's quite interesting to kind of look at this one. And while this is up, I'll answer some of those questions. So Peter's question is an interesting one. Peter Crees asks, would this have been better as a completely new high-speed line alignment? I'm in two minds about this because yes, it would be great. It would have been great to open it as a new high speed line, but I mean politically wasn't happening. The reason this work was happening, the reason HST exists, the reason APT was being developed because they didn't want to do new high speed lines. So politically it was very difficult. You'd have struggled a lot getting it through the southern end of the Cotswolds. That would have been a nightmare. That would have been really, really difficult. But in terms of from a railway ops perspective, yes and no. There are substantial sections of the Great Western that are 4-track, which allows you to run a differential. It makes it easier to run a differential. But if you look at the timetable now, along the Great Western, it's full and it's difficult to squeeze much more out of it, and the challenges come from running those non-stop services. You know, the non-stop services, much as on across the rest of the network, that mixture of stopping slower and indeed stopping faster, the mixture of stopping and non-stop services really hampers capacity. Also, if you built a new high-speed line, you would have ultimately avoided quite a lot of the reconstruction work. We're having to do multi-billion-pound reconstruction work. You know, it's £1 billion at Reading to do the work at Reading. It will be £1 billion to do the work at Didcot. We've spent a hell of a lot of money on grade separation through London as well. So there's a lot of physical work that's had to be done to essentially create an online high-speed kind of railway. So yeah, it would have been better as a new high-speed line, but politically not really going to happen. But yeah, good question, Dave. Was the Severn Tunnel included? No, it wasn't. I guess the South Wales Main Line to Cardiff, etc., was well out of scope. Yeah, absolutely it was. Yeah, I'm afraid. Barry Jones points out that he could watch the acceleration from his desk at West Drayton. There we go. Twyford. Let's have a look. Let's go. Let's find. Good God, I'm now going to try and find Twyford. You're going to laugh at me, so I'm just going to type in Twyford. There we are. Twyford. There we go. We've gone to Twyford. Excellent. So what we're going to do is, if I zoom in on, where are we? Twyford. Everyone, tell me where Twyford Station is. I'll tell you what. Let me turn. There's. No, there. That's going to be the. Surely, is it? Where's the? Oh, here. No, that's not it. This is the problem with this. Oh, I'm miles away from. That's not Twyford. That's the wrong Twyford. That'll be why. It's gonna be Twyford. Surely it's there. That's gonna be it. That's the one. That'll be Twyford. Surely. I don't know where Twyford is. I suppose I could just trace along. That's not Twyford either. I could just trace along here and find it, couldn't I? There's Pangbourne. There's Purley. Someone shout me when I'm getting Goring Gap. Oh, it's got to be further this way, isn't it? Oh, I'll tell you what. I could just look at here and find out where it was. Twyford is the other side of Reading. Okay, understood. I don't know the Great Western Line this side as much. It's Twyford. Oh, for goodness sake. There we go. So this map is from the mid 20th century, and I'm interested to see if we can see the realignment on here. I'm not sure we'll be able to. Let's go into the. Actually, there's a 125 inch here that might cover it. I'm just curious to see if we can see that. Yeah, you can see there's a bit of a kink here. I wonder if. Yeah. Oh, yeah. You can sort of see it. You can sort of see where they've done the physical work, altering the. So if we go to the other side as well, perhaps just to have a look at what the geometry is doing. Yeah, you can. Not quite as easy that side, but I think you can see that there's been a change. I brought NOS maps up because I reckoned that you'd be able to see a bit of a. I'm in big face, aren't I? Good, excellent. Let's go. I think you can just about see. You can just about see the change there, where they've slewed the track. You can they've slewed. Yeah, you can see they've slewed the track this kind of southwards. On the sort of this side of the station, you can see that the fact the station's been substantially rebuilt as well. Certainly on the kind of this side, you can see the flat roof elements. I think here, right? Although I might be corrected. If basically there's quite a lot of platform reconstruction work, as we can look at. Yeah, I know I fixed it. Everyone's behind me a little bit. I fixed it. Sorry. It's fine. It saved the embarrassment. You got to just look at my sweaty head while I was trying to work this out. So there are a couple of interesting things happening at Twyford. So. One of them was that they had to reconstruct one of the bridges. Interestingly, they demolished the bridge by explosives, which is a bold choice. Cutting a pier back and doing some reinforcing concrete doodad, and then essentially put in a flat deck to get the new alignment they wanted. So that's quite interesting. So substantial amount. Yeah, to allow the slew, they needed to set the central pier back by a metre. So quite a substantial cutting back. And putting new spanners. That's quite substantial stuff. So concrete board piles sunk to take the thrust. That's all very interesting civil stuff. Fine. So they did bridge reconstruction. They also had to reconstruct the platforms and the track work, which is quite interesting. So you can see there's kind of before and after work on the platforms where they've essentially the fast lines here have a platform No, they don't. So, oh, there's even a nice bonus HST there in the background. What's nice is a nice cross section here showing the before and after as well, which is quite nice. So it's showing the previous positioning and then the proposed positioning. I take it this is, yeah, it looks like they've, yeah. Anyway, I digress. Everyone's saying can't see it. You can see it. You did see it. You saw the map now. Yes. So anyway, nice cross section from the early 70s there, showing the new platform and formation. It's a nice high quality publication. You know, the IC Journal doing a nice job here. These are some nicely recreated sections. Very nice. Even you can even see the ducting for cabling. It's just like this is basically looks like a modern. This is a modern cross section. It's familiar. It's got a nice crossfall. It's got some drainage. Classic 300mm carrier pipe. All good stuff. You can see they've got F23 sleepers shown here, which is not accurate actually, because these have a flat shoulder, which means they're probably. What is this? Yeah, they're probably F27s at this point. Anyway, I digress. What else is going on? So they're talking about the fact that this work took a long time, particularly the platform work, but they took advantage of the existing crossovers to basically divert trains away from the work and then back onto the main line. So they actually used the diversions using the crossovers to get around it, which is kind of interesting choice there to do that work. Yeah. So what else we got? We've got they've removed a canopy on one of the stations. They kind of removed the work in order was, firstly, they removed the up main side canopy to buildings on the island platform. They excavated and repositioned the main trunk signal and telecommunications cable with great care by hand. Temporary barriers provided to enable earthwork to happen without the cable getting smacked to bits. A new platform was constructed in the clear at the west end and in a trench behind the existing platform wall. They demolished and took away the old platform wall and filling. They removed the upline. They excavated to formation level, laid a new formation and drainage, and then they unloaded track ballast, laid the track on top to the new alignment, completed the ballasting, slewed the track to alignment, and then they re-railed it with continuous weld. So that was with jointed rails. They then re-railed it in CWR and re-stressed it. There you go. And all that stuff happening in a period of, it's a slightly late start on the Friday evening. So this was basically happened over a let's see, yeah, it's not bad, is it? Over 2 long weekends. It's pretty impressive work. We're on page, I don't know what page out of what we are. I think, did we start on 210? Everyone close your eyes. I'm going to flick through pages. We started on 207, we're on 214. There we are. And we're about to move to 215. The only issue they had was that there was a load of rain that flooded the construction work. Whoops. It happens. So at Purley, what happened at Purley? They slewed the main lines about 1.5 meters to get improved speed. That's considered a big realignment, by the way. It doesn't sound like much, but anything over like a 150mm slew is considered a substantial bit of work. So to have 10 times that, to have nearly 1.5 meters of slew, that's nearly a gauge. We often measure slew at that point. We'll have to talk about a gauge of slew, which we mean track gauge. That's quite a lot. Door Hanger 93 is just pointing out that all those stats were per wheel and the electric locos were all Bobos, whereas the big diesels were Cocos. Electric is still lighter. Thanks, Door Hanger 93. Gareth Williams has just sent the number 207 to me. Oh, that's right. That's the page numbers, isn't it? An interesting question from Matt Reed, actually. When was the first tamper used? The first tamper was used... We started rolling tampers out in a big scale after the Second World War because there was just a shortage of people, shortage of skilled people. People didn't want to go back and work in the railways, or they'd been shot by Nazis. So we had lots of fewer, or by ourselves. You know, it happens. Lots of fewer people wanted to work on the railways, so we needed to mechanise at a rapid pace. And it was also seen as an improvement of safety and also of productivity to automate. But we'd seen tampers quite a lot earlier than that. I think the first tampers were in the early 1900s, the 1910s, I think, possibly the 1920s. But it's all in Andrew Dow's book behind me. So if you want a really interesting P-Way book, Andrew Dow's The Railway Track is honestly fantastic. Here we are. There's lots of questions come through. Like people pointing out that I'm still in Big Face. Yeah, I know, I got there. Are there any other lines that you think would benefit from not going to 125 miles an hour? Not that many, because it would generally make a massive hit to capacity. Let's see. I think it's Typhon near Winchester. Yes, it is. 5 miles east of Reading. Yeah, I'm just it's not doing a very good job. The geography was at that point. If you replace the intercity service on GWR with a new high-speed line from Farringdon to Cardiff, maybe beyond, how many intermediate stations would you skip? Well, as many as are on the map, quite a few. You'd still want to call it. I think you'd still want to call it places like Reading. You'd still want to call it Reading, certainly, and Bristol, certainly, Parkway. I don't know what I'd do if I did I still don't think I would do a high. I'm an eye about the value of a high-speed line. I think rather than building a high-speed line along the Great Western, I would actually build a high-speed line from London to the Hampshire conurbation, and then on to Exeter, and actually create a new high-speed line on that alignment, providing a connection through, and then a much faster connect. The benefit of that being that you connect Cornwall and Devon into the country much more. That's rather than them having to travel halfway, quite a substantial way up towards the Midlands before they can go across to London. That's what I would do. Anyway, so you can see there's some work at Pangbourne as well. The platform is being demolished at Pangbourne Station, because they had to slew. Oh, nearly 3 metre slew. Should we go over to Pangbourne Station and see what we can see? Pangbourne was. Let's keep going this way. This is the NLS website, by the way. If you've never come across it, it's fantastic. Honestly brilliant. Oh, look, it's. Alright. It's Reading. Look at all this stuff at Reading. How much of it remains? Less. Less of it remains. Quite a lot less. There you go. Strange purple roof buildings. Anyway, I digress. We're going to Pangbourne. Let's go to Pangbourne. Pangbourne. Come on. There's Purley. And there's Pangbourne. So, let's have a look and see if we can see an obvious alteration in the position of... a bit, but... Oh yeah, no, you can see. The mains are the southern lines there, I presume. And you can see that they've been slewed. They've actually been pulled inwards a bit, by the look of it. That's... Yeah, I mean, obviously the map might not be quite aligned, so it's kind of a bit of a guide, but yeah. What would be nice is if you could... Yeah, I'm not sure. I think... Yeah, I can. Anyway, I'm not sure. I was hoping it'd be slightly more, slightly easier to spot that actually. But anyway, Chippenham. Interesting. A down line was transferred from the former down platform to a rebuilt platform face. So it's quite a lot of substantial work going on. There. So there we are. Various redundant track connections removed. All that good stuff. To provide the correct cant and curvature for 125 mile/hour running. A fine alignment, together with the associated cross levels, the cant, had to be established throughout the route. The work commitment required additional technical staff as well as Halad gangs. I've got a Halad kit somewhere around here. Halad is where you basically go out. Well, there's a mixture. Halad gangs are going out and actually measuring the radius of the track using a metal string line, 20 metre long, and then you measure the chord. You essentially measure the distance from the string line to the curve, and that gives you a versine, and then you can calculate curvature through that, and then by overlapping halads you can get geometry in a long period. We don't measure geometry like that anymore. It don't make no sense to do it because we've got CAD, we've got computer aided design, and we can bring in a 3D representation of the alignment and alter that. We don't need to use halad, but I still use halad kits for measuring. That's a fly. I still use. You just watch me murder on a stream. Crikey. We still use halad kits to measure track radius. We'll take a few overlapping measured curves for things like gauge clearance, where you can't do a topo survey, but you want to get the track radius in order to get your curve overthrow. Oh, I'm just chucking all the bits in here, and we're already nearly an hour in. I thought it was going to be a short one. It's ended up being a long one. Oh, crikey. Not much work was done on the approaches to Paddington because the alignment in Paddington was not bad. So if we go to Paddington, you can see that the coming in actually, interestingly, the alignment after there's an 85 mile an hour approach, but only because that'd be the down. So that's going away. Oh no, that's arriving into. So basically, you're decelerating coming into London anyway. So I presume that's why that was acceptable. But not. I guess they didn't need to do much. The alignment's pretty straight through London, so I don't know if they actually need to do that much. What else? So the final alignment. So they're doing the Halad work. So they needed to bring in extra technical staff. They're all, yeah, here we are. All the realignment schemes were carried out using metric units, with the cant designed in increments of 5mm to a maximum of 150mm, while verse lines were measured in millimetres on an overlapping chord length of 20m. Oh, there we go. That's saying exactly what I just told you, which is nice. On very flat curves, a chord length of 40m was used. Yeah, that's fine. We do that. The new high-speed alignment was designed using either Short's graphical method or Bartlett's arithmetic method. We don't need to use those anymore, thankfully, because we have CAD. But it just shows the geometry design is a bit of hard work. Don't short ones often end up being long? Yes, they often do. That is basically, if I say it's short, it does end up being long. Why did the bit near Paddington decrease from 90 to 85? Probably a realisation that it didn't need to be 90 for the fact the trains were decelerating on the approach. I'm going to hazard a guess at that. Curves with a very flat radius were set out by theodolite using deflection angles. The alignment was monumented by the provision of 75mm square wooden pegs painted white at 10m intervals. We don't need to do that anymore. As far as possible, all track was monumented, including straights. The minimum standard interval provided between the back face of rails was 1830mm. That's referring to the... nowadays we do it as 1970mm as the minimum. But basically it's referring to the track interval, so the 6 foot between the two tracks. Wherever practical, okay, track made in parallel, yep, fine, lovely. So let's just talk about design. No, there's a load of design there, marvellous. Cant, curvature and tangent points are marked permanently on the track by Scotch cal, plastic letters and numerals. Remember my Rail Live episode when I was talking about these things? Except they're using them for... yeah, I don't know if any of these are left on the Great Western. Can anyone confirm to me whether any of these exist? I'd say that all the rails have been renewed and they've probably these are long gone. But what's interesting is you can see some examples of the geometry here and how they'd mark it up, which is quite nice. So yeah, quite like that. That's nice. Here's an automatic ballast cleaner, because of course one of the main things they had to do is go through the route and reballast, because a lot of the ballast was not in great condition. Because historically, the Western region used large quantities of limestone ballast from the Mendips. Limestone ballast is not good enough. It crushes and also is washed away. It's limestone. It gets washed away. So it is no good. Barry Jones, 20 metres, don't you mean one chain? No, I don't. One chain is 18.288 metres. Yeah, no, I don't. Chain in metres is... Oh, no, it's not. It's 20.1168. Sorry, I was getting confused between my 60-foot panel. Yeah, it's... I don't mean one chain. I do indeed mean 20 metres, but I know you're teasing, Barry. Slew is how we describe moving the track laterally. Yes, it is. Thanks, Murray, for answering questions. Yes. Jack Corsi asking what a slew is. Yes, slewing is where we basically pick up the track and move it to one side. And essentially, the way that a tamper works is it picks up the track, moves the track by picking it up into its appropriate design position. It has a load of tines that go in that vibrate, and all the ballast then consolidates up underneath that track. There's a little pressure gauge saying, is that track now being supported horizontally and vertically in that design position? Is enough ballast tamped up, kind of consolidated up around it, that if the grip on the rollers that are holding the rail in place can release, the track should stay in place? That's the theory of the tamper. That is indeed how that works. So, plenty of reballasting, and they used a huge amount of... they used the automatic ballast cleaner a lot, quite a lot. So you can see they recovered... quite a bit of the ballast, so they use quite, if it's clean, they can recover it. But in the case of the limestone stuff, the majority of it had to just be sort of spat out, and they found it useful. It could be discharged into wagons to use. The rejected material is particularly useful on embankments, because you can use the spoil for widening or raising cesses. So rather than having like the embankment like that dipping off away from the track, you can rather than it being, let's use my bendy knuckles, kind of like that, you can sort of slacken it, widen it, and then you've got a bit of space for a person walking next to the track. So that's a good thing. So that's fine. Also, what's interesting is they were using a bituminous emulsion. To spray over the exposed formation once the ballast was cleared. A technique has been developed in which the bituminous emulsion can be sprayed over the exposed formation by means of a bar fitted immediately behind the cutter bar of an automatic ballast cleaner. So there's a cutter bar that goes in and basically scrapes along and scoops the ballast up. So that's quite interesting. The emulsion impregnates the top surface of the formation and provides an impervious layer under the ballast. The treatment is to be recommended for dealing with wet sites where there's danger of the underlying material softening. So that's quite interesting. It's a bit of a novel thing. We don't really do that these days. We don't use a treatment like that anymore. We generally go for less permanent treatments. Anyway, quite interesting. Also blanketing, so using a sand blanket, so there's the sand blanket, and then sheets of polythene. Yeah, so they use polythene sheeting as well. So this it's interesting because there's different formation treatments here that you can see. So wherever clay is present, clay is a particular problem. Let's see. Here we are. Gareth Williams is asking, apart from Penmaen Mawr, which other quarries does ballast come from? Oh, I don't know actually. I knew that a good chunk of it came from Penmaen Mawr, but I'm not. There must be some other sources that we get, but I'm not entirely sure. Yeah, limestone has a low hardness. Dolomite is a little better, but not much. Silicaceous materials are better. Granite is the material of choice for our ballast these days. So there's also talking about drainage as well. If there's no existing drain at acceptable depth, it's essential to provide a new drain. A convenient form being a 225mm diameter perforated pitch fibre pipe with precast concrete catch pips at, interestingly, 40-metre intervals. We generally use 30-metre intervals nowadays, so that's quite interesting as a change. So you can see some of the slight changes we've got in our design approach to things, which is quite interesting. Barry Jones is suggesting Meldon for a source of granite. Yeah, that sounds familiar. I'm not 100% sure on that actually. Never really thought about it. I should do an episode on ballast, and I should do some investigating. I should go to a ballast quarry. That'd be fun. Anyway. Badminton line work. So we talked about kind of the work on the main Great Western, but also the Badminton line is essentially the high-speed alignment really that takes you to Bristol Parkway and to the Severn Tunnel. Analysis of the civil engineering workload on the high-speed routes indicated a heavy concentration of works between Wootton Bassett Junction and Bristol Parkway Station. This line, which provided a more direct route to South Wales, as we know, was opened in 1903, laid in a variety of clays, often in deep cuttings or on high embankments, made from the clay excavated from the cuttings. Much of the route had been relayed with CWR on concrete sleepers in the early 1960s, but the ballast depth was generally inadequate. So this is a problem. So they knew that they'd have to reballast, and that would require a lot of additional either excavation to maintain the level of the track, or lifting the track to account for an extra 100mm, 10 centimetres of ballast. So without effective formation treatment, clay working, basically there was clay working up. They were having clay, wet spots, slurried track. You might see slurry track every now and then. Some platforms are adjacent to it. You can see slurry coming up. It's often the clay. Lots of it in London with clay, with all the clay that the tracks are laid in. So there was also wide sleeper spacing, which is not great. So all this stuff really degrades dynamic performance of the track. And so there was a proposal that there would be an extensive program of replacing the formation being the stuff under the ballast, which is the rocks that kind of form the track. You can sort of see it quite nicely in this diagram here. You can see the sleepers, you can see the top ballast, and the bottom ballast generally is underneath the sleepers, and then underneath that is the formation, the subgrade in the formation. And what's quite nice here is you can see a geosynthetic being placed, probably just polythene at this point. You can see a geosynthetic being placed. You can see the hoppers dropping in ballast on top. Actually, it might be sand. Yeah, it's sand being tipped at the moment, which they'll spread over it and then put the ballast on top. Just another form of choice of using different treatments to deal with different levels of problems with formations. Granite is 65% silicon oxide approximately. Very high silicaceous content. Thanks, Graham Harth. Very useful input. Is this another geologist over from North America? Graham, are you putting the work in from the other side of the pond? Let's see. So lots of work going on. So they decided that it just basically couldn't do it, and it was estimated that this is worth noting, by the way, because it gives an idea of the difference between doing a blockade and doing work long term. I've written about this recently, actually, in Rail Review. The demand on resources would have adversely affected essential work elsewhere, so it was decided to close the Badminton line between Wootton Bassett. Oh wait a minute, I've skipped the important bit. The important bit being the extensive programme was started in 1971. When the situation was reviewed in late 72, it was estimated that there still remained, so they actually started doing the work in nights, nighttime sessions. There still remained at least 3 full years of weekend work on this line alone. The demand on resources would have completely dominated doing work elsewhere. They just would have wrecked the programme. So it was decided to close the Badminton line for 5 months and just do all the work in one hit. It's quite that's a hell of a blockade though. 5 months, a long time. So this is all the work that they needed to do. They needed blanketing and associated drainage for 9 miles, reballasting and bitumen spraying 12.5 miles, lifting for 8 miles of track, taking up 6 existing crossovers and laying 3 pairs of new 40-mile-an-hour crossovers for reversible working, the reconstruction of the centre spans of 2 overbridges for more headroom. See that the headroom, the loading gauge was not any better on GWR than it was anywhere else. Enlargement of 240 refuges in Chipping Sodbury and Alderton tunnels. That's pretty substantial work, expanding inside a tunnel. And then providing platforms on embankments and recesses in cuttings for staff to actually stand clear of trains. So a lot of extra work there. Mermaid wagons are just the ones that can tip. You can see they've got this sort of tip. They can sort of side tip like this. Not quite sure, but someone else can come up with why they're called mermaid wagons, I'm sure. So, they're referring to it as manpower. It's outdated now, we know that. Staff consultation held at an early stage, and much of the success of the job was due to the very willing cooperation of staff at all levels. So agreement with the staff as to what the work would look like. Funny that. A pattern of 3-shift working was agreed with half-an-hour overlaps of shifts. No work was programmed between 23:59 on a Friday and 23:30 on a Saturday, allowing a break for gangs to change their shift pattern and for equipment to receive maintenance. It also provided valuable recovery time where other labour or plant could be drafted into the job to make up for any delays incurred during the week. So there we go. A break, basically all of Saturday was a break, which is nice, you know. Initially, 36 men were programmed for each shift, supported by supervisors and supervisors and technical staff who worked the same shifts and remained with the same gangs. So there we are. So you're working with the team that you're familiar with. It's found that productivity could be increased by building up the day shift and reducing the night shifts, but the total numbers of staff remain reasonably constant. There we go. Wagons were a critical resource. So a huge number, 30,000 tons of sand, 100,000 tons of ballast. So a huge amount of wagons, wagon moves there required. Ballast was conveyed from Tintern Quarry. There you are. Google Tintern Quarry, see if it's still doing its thing. Probably is. That was shipped in directly. 125,000 tons of spoil were taken away in Grampus wagons. There we are. And they used a tip at Stoke Gifford to take that material. That's a hell of a lot of material, though. You could kind of raise the level of several fields with that much material. So quite a lot of stuff there, and obviously kind of quite a lot of... in terms of the total amount of plant, 2 trains of 25, so 50 mermaids, these 12-ton side-tipping wagons, 6 16s. Oh, crikey, I can't do 6 16s. That's so many times 16. Plus 10 spares of sea lines, which are the ballast hoppers, 8 trains of Grampus, 20-ton spoil opens. There's a twin jib track relaying train, an automatic ballast cleaner, a single jib 15-ton crane, 2 Hymax, 3 track excavators, that's exciting, 1 JCB for excavating drainage trenches, GTG lifters, 2 placer tamping and lining machines, 2 placer 7s, and 1 regulator. There you go, a regulator is for shaping the ballast. Tintern as in Abbey. Yeah, I think so. Tintern Quarry closed, I think. F. F's in the chat for Tintern Quarry. Probably a good thing for the people in the Abbey. Anyway, so crikey is what I can say to all that. It's a lot of work being done there. And then there's kind of a bit... The paper includes a bit of like how they organised the actual sort of possession work and how that worked. They only permitted trains past, allowing trains into a big blockade, so what the safety scheme was. They talked less about safety and more about smooth running of the project. But let's face it, the two were really hand in hand. But not as much discussion about safety here as you'd expect from a modern paper, let's face it. Progress of work. There was some heavy rain. Generally, the weather was hot and dry. It's doubtful if such an ambitious programme could have been accomplished with less favourable weather. So it sounds like the weather was pretty much on their side. There was a bit of flooding from the rain, which was an issue elsewhere as well. But okay, there was a challenge with the enlargement of tunnel refuges. So that was a bit of an issue. But they changed the plans to deal with that. Happy days. And there you go. And then they turned to fine levelling at that point. And then the last thing I think we're going to look at is the switches and crossings. So they needed to upgrade some switches and crossings. This is the way that trains kind of join and kind of conversion diverge. And so the various switches and crossings, which is showing kind of basically improvements. So with the introduction of CWR track, there's been a vast improvement in the quality of ride on plain line. That's not switches and crossings. Positive steps were required to ensure that provision of a comparable standard of ride through switches and crossings did not lag behind. For a number of years, switch and crossing layouts have been simplified in association with signalling schemes which replaced traditional manual signal boxes, and motorised working of switches had enabled greater flexibility of layout. This ties in a little bit with my plan to reverse history on the modernisation plan, which everyone says was a failure because they've not actually looked it up themselves and worked it out whether it was or not. So we'll do an episode on the modernisation plan and why it wasn't a failure. But they're just pointing out the fact there'd been that simplification already. A plan based on anticipated renewal dates was prepared to complete the outstanding improvements to layouts throughout the route before the advent of high-speed trains. So there's alterations at Dolphin Junction. Originally it was sort of traditional double junctions, switch diamonds, yada yada. The new layout is entirely crossovers, so very much as we do nowadays. We replace all these double junctions and switch diamonds and so on with just having crossovers. Much more reliable, much more maintainable arrangement. So there we go. Runscombe Junction had like parallel running junction, switch diamonds, yada yada, and it was increased from 40 to 70. No parallel workings required, so only three crossovers were needed, which is nice. There we go, lovely. That's fine. They increased the overall length of the junction from 9 to 27 chains, so just showing how much the junction extends when you take that approach. Didcot East Junction here being remodelled from 40 to 70 again. Thingley Junction here. There we are, lovely. That's where the connection to the MOD depot is. Yes, so it's located on a circular curve. The main lines were slewed approximately 10 metres to the north. That's quite substantial. The cant on the circular curve was increased to 150 millimetres, and switch and crossing were relocated on straight track. There you go. Up trains from Bradford Junction now travel a half mile in the reverse direction along the down line to new crossovers. That is, that's kind of fine, but not great in honesty. So not a huge amount of optimization there, but anyway. Improving running through switch and crossing work, which had been in track for some years, so they were doing surveys at other junctions and improving those. Southall West, Scowers Junction, Swindon, they were doing cant and gauge recordings, yada yada, all that good stuff. Checking that everything was fine, worn switches, rails, pads, pantry clips. And consideration of provision of glued insulated rail joints. That seems like they're wording it like it's novel at the time. Something that we just, almost all the joints that we include is. If you want to go to Thingley Junction, actually have a look at Thingley Junction. Can we do that? Do you think? Can we find Thingley? Surely we can find Thingley. Can we do it? No. Let's go for the old F5 and get this working. Thingley. Nope, that's not Thing. Right, let's go back to here and then go up to here. Where's Thingley? Oh, it's not on here. Thingley Junction. It's down at Box Tunnel. Okay, we can go down there. We can get down to Thingley. Fine. We can do it. Let's do it. Let's go down to. Let's see where we're going down. Go down to here. And find Box Tunnel. Let's get. It's good old Bristol. Box Tunnel is up here. There's Box Tunnel. So it's just a bit beyond it, wasn't it? Was that right? It was just beyond it, wasn't it? Who's here to provide me information about Box Tunnel? Come on. Tell me about Thingley Junction. I guess it's down here. Let's see. Here? Thingley? No, that's not. That's Bathampton. Where was it again? Everyone's back. Cover your eyes because I'm going to flick through here quite a bit. Thingley. Oh no, it's the other side. It is the other side of Box Tunnel. Okay, fine. I'm flashing track up and down quite a bit. I'm sorry. The page is up and down a bit quite. I'm sorry. There we go. Let's try again. Alright, Box Tunnel. Fine. We're going to go this way and get ourselves to. Okay, fine. Go this way. Was that it? There's Thingley. Okay, Thingley Junction. Right, marvellous. So if I do this now. Oh, yeah. You can see there's quite a substantial slew. Oh, nice. Let's zoom out a bit. That's quite nice. That's actually useful. That's the most obvious change in the geometry we've seen. So you can see it's quite a substantial slough. In fact, to the point where you can see the original footprint there. That's quite a substantial alteration in the. Yeah, if we kind of get the halfway, you can see. Let's get it to exactly 50. Yeah, you can see that it's going to kind of tying in by this bridge, but by this point you can see the track is actually maybe a little bit less on the. That would also be good if it loaded. That'd be nice. Yeah, you can see that the main lines are sloughed quite substantially across, and then they come. Come on, the new bridge kind of looks like a new bridge has been built there, doesn't it? Yeah, it does. Interesting. Yeah, you can see, and then I presume it will come in by. Yeah, come on. Yeah, and by that point it's then come back in. If my internet is being weird. Anyway, yeah, there we go. That's quite interesting. I like that. That was a bit of an insight into what had happened at Thingley Junction, the weirdly named Thingley Junction. Thanks, Tim. Thanks, everyone saying, what the hell, why can't you find this stuff? I've never done any work on the Great Western. I literally never done any work on... yeah, I've not done any work on the Great Western. It's the only area I've not really done any work. I've done work pretty much the rest of the network. But the actual Great Western are not. Anyway, let's see. Also, I know time is going on. This will definitely be finished shortly, I promise. Here's a nice swing nose crossing. This is an exciting thing. The fact they're installing swing nose crossings is a bit of a mind blower. You see, they talk about Dolphin. So you can see that they actually propose what they call Mark III swing nose crossings to a crossing angle of 1 in 21 to allow improved riding and speed. And they're saying that from a riding point of view, this trial has been successful so far. Weirdly, the Western has trialled swing nose crossings multiple times, and it's always the Eastern that's rejected them on a national rollout basis. I don't know why, but yeah, in any case, we need more swing nose crossings in the UK. It's funny that the Western have been trialling them. It's one thing where I can definitely say the Western are doing better. Yeah, there are a few misalignments between the different maps, but that one you can see by the fact that it ties in and other things are kind of online with it. That the one we just put up was viable. Anyway, you can see the remodeling of the junction here. You can see the double junction and the diamonds, whereas here you can see it's sat across over. This is a much better layout than this one, even though it takes up a lot more space. So there you go. Ruscombe Junction before and after. There you go. I think that's quite an interesting little observation to compare between those. And there is a section here on safety of staff, and I think it's worth just having a look at that before we kind of conclude. The hazards to staff who have to be out on or about the track are twofold. And this is really about the future safety rather than the safety of the workers during the work. But anyway, speed of approach is that a quarter mile every 7 seconds at 125 miles an hour. And the other thing is the aerodynamic effect in confined spaces such as tunnels. So these were considered carefully. So they had guidelines for staff safety on high-speed routes, which has been discussed with the Department of Transport at the time. And to overcome the longer distance needed for sighting, gangs were provided with portable apparatus connected by cable to a warning device at the work sites. They put in permanent protection arrangements. So on the sharp curves at Alderton Tunnel, a permanent installation was provided, which is actuated by an approaching train through the track circuits. TOWs, early form of TOWs, I dare say, maybe not even that early. In Chipping Sodbury and Alderton, we talked about the fact that the refuges had been deepened and handholds were provided. And also refuges provided at steep cuttings and where there are steep cuttings and retaining walls within 2.5 metres of the nearest rail. So there you go. Quite a lot of work done, but interesting to look at all of that level of work. A huge amount of engineering work going on there just to kind of deliver this scale of speed increase. Well, it seems kind of modest, right? That increase from about 90, 100 miles an hour to 125, but it shows how much work was involved. Quite substantial amount of work. I've previously written that not a huge amount of work happened, which is was a bit unfair actually to the level of engineering work that went into it. I kind of take that back. The efforts to achieve the required track standards culminated on the 14th of September 1976, which is when the final track testing runs provided did the 107 miles from Paddington to Westerly Junction in 63 minutes. Averaging well over 100 miles an hour, which is great. So there we go. And it's talked about the fact the efforts needed to maintain the standard will, in all probability, have to be just as great. So it's a key warning. Track conditions are being monitored each month using the Black Box portable recorder, developed for the purpose by Western Region staff in association with an electronics firm. which is the picture that we put up at the start of that strange box. It's set up over the rear bogie of the last passenger coach in a normal HST. It gives a 5-trace record showing vertical and horizontal accelerations and displacements together with mileage. And those, they're similar to those produced by a Hallad machine, familiar to track maintenance staff. This is the same sort of thing that we use. We use the traces now in design to check for track quality issues, and allows us to keep on top of the track quality, track condition. So here you see the machine placed at the back of an HST. I don't think you'll find one there now, I'm afraid to say. I wonder if any of these have been preserved. I wonder if there's one at the NRM. Bob, if you're watching, or Ant, if either of you are watching, Ant, you're too busy. Bob, sometimes you watch this. If you are watching, it'd be good to know if there's one of these hidden somewhere. It'd be good. Anyone with any knowledge, let me know. So there you go. As the high-speed service has developed, it's been found that the air suspension system of some of the new Mark III coaches is very sensitive to vertical defects, particularly slightly dipped joints. As a result, the follow-up of blemishes in the vertical profile has been intensified. There you go. It's too early to be sure of the rate of deterioration and level of maintenance effort which will be needed. However, full records are being kept in order to establish these as soon as possible. Records which were thrown in the bin by Railtrack and its contractors. Fantastic. So there you go. There is high-speed track on BR Western region. It's a fab little paper, I think. It's really nice. The key question comes up is, could we do this nowadays? Can we do this nowadays? Well, the reality is we have done major schemes like this quite a few times since the Great Western. We've done the work on the work that was done on the Great Western was followed up on the East Coast Main Line. Work similar to this had been done on the West Coast Main Line when the West Coast Main Line was modernised. We have done 125 mile an hour improvements since then on the line between Derby and Birmingham, actually, that line, the cross-country route. Ironically enough, a line that very much should be electrified, but isn't. But that was upgraded to 125 pretty recently. I think that's the most recent 125 mile an hour upgrade we have seen. The challenge is not so much an engineering one. Track access is much harder because there's so many more trains. We have a fragmented industry, which makes this kind of joined-up work a lot more difficult. But that can be potentially improved if GBR remains a thing that we're going to do, which it might not, newsflash. That might help, but probably won't make much difference because the intention with GBR is still to keep it pretty fragmented, because otherwise people can't make any profit. You can't make profit when it's one big monolith. You can pretend that you're making profit when it's all split into lots of bits. In any case, Murray Christensen, you make a good point. Do send questions, by the way, folks. You did hear of track recording equipment being put in service trains. Yeah, there are lots of trains running right now that do the stuff that train does. All the IETs do. The Pendolinos do. I think pretty much all of the new stock, certainly the new long-distance stock since the Pendolinos, has got some form of track recording analytics within it. But certainly the IETs and a lot of the new stuff do. I think the Flirts will as well. So yeah, that's certainly there's certainly that stuff. But the issue is about doing this nowadays is a bit what Peter Creese's question referred to a while back, which is the issue isn't so much an engineering one, or even a political, or a technical, or it's an operational one. It's the fact that if you increase speeds to 125 miles an hour, if all the stock is not running at 125, you will reduce capacity, and this is why. When I sat in the Transport Select Committee and was asked about 140 mile an hour running on the East Coast Main Line, ignoring the fact that you can't really do much of it anyway, increasing to 140 miles an hour will decrease capacity on the East Coast Main Line. So it's not a good idea that we do 125 mile an hour upgrades unless we have an electrified railway and all the trains have the same performance and all the trains are 125 mile an hour capable, and that makes the timetabling much easier. So, other people have pointed out that there is, the 125, the HST, did enable this work to happen because it meant that existing signal blocks could be retained, which was, which certainly helped, and in braking distances, absolutely. But there's a lot of physical work, and I think it's worth kind of remembering that a lot of physical work happened to enable the HST to run on the Great Western, on the East Coast Main Line, and indeed upgrade work on the Midland Main Line as well. So, there we go. We're going to get this one done before an hour and a half, which is still not an early one. This is an episode which is available on audio only format. I am a few episodes behind. They're all going to get dumped in. Audio only people won't be hearing this until it's too late. But anyway, they'll all be getting dumped in because I have to do it manually. When I was going on holiday, I just couldn't do it. But I'll be back up to date with doing these again. They'll be uploaded tonight or tomorrow at some point. And what else? So thanks for listening, everyone, in audio-only format. Next point is that you can support this. Patreon.com/GarethEnnis. Times are tight. So I don't feel bad for anyone who is a Patreon supporter to drop down to the lowest tier. That's fine. But every little helps. So if you're not a Patreon supporter and you like this and you've been watching this for a while now and you kind of want to feel like you're part of the community, then I can recommend a great way to feel like you have a parasocial relationship with people is to subscribe to their Patreon. PayPal.me/GarethDennis if you have no interest in a parasocial relationship with me, which I can strongly recommend, to just throw mean words at me or the occasional penny or two. And GarethDennis.co.uk/Discord is where all this chat that's been happening continues. There's an interesting question that David Shepherd's asked, which we'll cover in a moment. Next week's episode, I'd said it was going to be a news one. It is going to be a news one. It's episode 131, new government, new ministers, but what's next for UK Rail? Yeah, well, indeed. We shall find out. Hopefully in the episode we'll go through. We'll do some news. We'll have a general chat. We'll have an open chat about what we think. We'll talk politics. We'll do all that stuff. So if you're not interested in the politics, you can avoid the episode. But if you're kind of interested to know what all the we'll try and run through all the big things that are floating around at the moment. You know, what are all the big things floating around that are needing resolved? Well, strikes, massive industrial relations problems with the railway at the moment. All of the mess of the timetables and the fact the timetable is still running reduced everywhere. All this stuff. What the hell is going to happen to it all? Is it going to change? Is it going to be better, worse? I don't have all the answers, but we can chat about it together as a little team and work out what we think might happen. And I might have some insights and some other stuff. Let's see. But I'm going to go big face because all that really remains for me to do is correct my credits, which still say thanks to John Stone. Is to which I've now done. Is to answer David Shepherd's question first. David Shepherd asks, has the In-City 125 work that's already been done something that's making it harder for pro-rail people to argue the benefits of high-speed rail? In a way, yes, because the fact that we increase speeds to 125, 200 kilometres an hour on our existing network, extensive sections of our existing network, has indeed made it a bit harder because we have quite good long-distance services, and it's made it harder for people to understand why you need, why you need to improve speeds. But this is why you need to explain the bigger picture. Is that actually the 125, running those non-stop services causes real challenges for capacity. Matt Reed asks, when's the next page turn? I don't know. Send your suggestions in. All Patreon supporters, you can send your suggestions into the Discord. There's a huge pile of suggestions that I've been that I need to peel through. I've been a little bit kind of running behind on Rail now. I need to get ahead of things a little bit, but I will attempt to do that between now and the end of the year. Try and get ahead of things a bit. Get some more guests in. Get a bit of a more diverse mix of guests. British Rail does sound like a good name, doesn't it? Well, Great British Railways has an awful lot of redundancy about it. I feel like you could shorten it a bit. Anyway, right, you've all been lovely. Sorry for being very tired and a little bit staticky here because there's a thunderstorm going on outside. And also for being late. Also, I blame the thunderstorm for that. I also apologise for the moustache. But I will see you all. Take good care of yourselves, and I will see you all next week to do a news episode. Oh, I was going to talk about holiday, wasn't I? Holiday was great. There you go, your little extra bonus minute. Holiday was great. But, not but really, several things I learned. Well, the buts were, firstly, the by far the best way to improve the feeling of quality of a city is to just get rid of cars. Ban traffic. We're in Ljubljana, and it was just so stark. Comparing Ljubljana to Trieste was the next city we stayed in, and then comparing, and then we spent time in Venice, where again, by necessity, there's no cars. But actually, the canal bits can be quite busy. But the joys of Venice is where there's no vehicular, kind of car traffic. Comparing that to Padova, which was really busy, and then Milan, which is also, nice pedestrian bits here and there, but actually right the way through the centre, it's really busy with traffic. The obvious thing that was just joyous about Ljubljana, just starkly better, was the fact that the centre of the city is pedestrianised. It just makes an enormous difference. You just cannot overstate how much of a difference it makes. That's the number one thing. The number two thing is how low average speeds are and how poor cross-European connectivity still is by rail. It's really difficult to plan in. Booking tickets is a pain. Don't trust Google. Don't trust Google's recommended timetabling stuff. It's useless in Ljubljana because the long distance buses and the trains It doesn't get updates whether the trains are changed, and it also the buses, because the buses have the long code number associated with each of them. When you click on one, it doesn't give the schedule for all the ones that depart that day. It just gives that one because it's got a unique identifying number. So it does, the open data in New Zealand does not work with Google, so you can't trust Google Maps, and it's not that much better. It's better in Italy, but it's not that much better. Croatia and Serbia's public transport is hopeless, particularly outside of the city centres. Public transport within the cities of like Belgrade and Zagreb is not too bad. Actually, Zagreb much better. Belgrade, mixed feelings. But anyway, them's my holiday thoughts. You can follow the thread that I did somewhere on Twitter. I don't know how you'd find it because it's probably buried in amongst all the other junk. But if you go back through my media on Twitter, you can probably find some pictures of me gallivanting around Europe. Also, Eurostar. Get rid of security. Just it's legally redundant. You don't need it. You can just petition government to just get rid of that. And also stop treating Eurostar like an airline. It's there are so many great staff, lots of them on Twitter who work on Eurostar, but I hate the way that Eurostar is run. Absolutely hate it. Hopefully the new boss will run it better. Anyway, right, that's enough from me. Everyone, you've been great. You got a little bonus holiday chat there. I did promise, didn't I? Anyway, right. Cheerio, everyone. Cheerio.